Hi class, this is the answer video for chapter 15's assignment, your SPSS assignment number 5. Now when you conduct a regression analysis, you would see at least 3 tables. Okay, you don't have to come up with this last table because it's available here. Now when you look at the 3 tables, the first thing you want to look at is this sig value in ANOVA table. This ANOVA result tells us that the variables, which is the predictors and the dependent variable, it's a good fit. So that's why it's significant. When it's significant, we'll then go ahead and read the other details. R over here is correlation. So as you recall from chapter 14, this digit, this number 0.76, is a moderate positive relationship. R squared, 579, you would look at it as a percentage, so it will be 57.9%. What this R squared means is that it will account, or it accounts 57.9% of the data, of the results, excuse me. And this adjusted R squared is also the accountability, but then it just looks into the independent variables. Okay, the next thing you want to look at is the coefficient. Okay, here it shows you the unstandardized coefficient and the standardized coefficient. For unstandardized coefficient, this beta value tells you the unit increase, because from here you can tell it's positive relationship, and as well as from here you could tell that it's a positive, so it's a linear relationship. So 0.017, that means that for every $1,000 income increase, 0.017 unit would increase in the likability of going to the restaurant. And so this is how you interpret the unstandardized coefficient. The standardized coefficient, on the other hand, would tell you the relationship, so it's positive, and the importance of it. So based on this, for independent variables, we could tell that this 0.729 is way bigger than any of the variables underneath here. It's at least 7 times more important. Okay, and it kind of tells us how to interpret it. However, before you do so, you have to look at the significance value over here. In regression, we do trimming for enter method, not stepwise. So what we're going to look at is whichever variable that is not significant, we would remove it. Okay. Now when you remove the variables, you would rerun it. And if you could recall, the numbers change slightly over here. Okay. Some of you might just based on the first model, which you shouldn't, because the values would change. You would always have to paste the table after you rerun the model, the analysis. So again, we look at ANOVA is significant, and the correlation is moderate positive, and it accounts for 57.6% of the whole model. And you could see that 57.5%, this is a better fit. This shows a better fit than the previous model. VIF is less than 10, so there's no concern with the data set. And here you could look at 0.759. It's very strong. And we would explain this when there's more variables. Now that there's one variable, you just have to indicate the sign of the standardized coefficient beta, and then kind of interpret the data as in, and then so from here as well, 0.018, that, an increase, 1,000 increase in income would increase 0.018 of the likelihood of people going to the restaurant. Again, this is significant. So it actually tells us that we don't need the other insignificant variables since they are insignificant. And this is the predictor of, people having the likelihood to go to the restaurant. So probably Hobbit's restaurant, the choice restaurant, they should target on people who have higher income level. So for the second question, we will do exactly the same. We would run the analysis, and then we will explain what are. So this is strong positive, and it accounts 70.1%, which is really strong, which is really good. The accountability is really big. And again, this is significant. VIF less than 10, so there's no concern with the data. And look, these two variables are significant, so these two are the predictors of the likelihood of people going to the restaurant. Now again, we look at this unstandardized coefficient beta. So every dollar amount you spend, an increase in every dollar amount spent, it will increase in 0.003 unit of the likelihood. So the unit would be, how you see from 1 to 5, how likely, very likely, or least likely. And then for this standardized coefficient, you will look at these two values. 0.649, it is 3 times more important than the total dollars spent in the restaurant. So in order to interpret this data, you would say you would report the independent, dependent variable, and the standardized coefficient beta. Those information are available on page 397. Those 4 items you need to report, as well as the VIF. And so here you could tell that, okay, what's their target market? So their target market will be looking at this value. The relationship is positive, is a linear. So you would say that, the bigger spender they are, the more likely they would be in the restaurant. So Hobbit's restaurant will probably need to target on bigger spender. In general, they just patronize the restaurant. So this, like, how much, like, it doesn't really say exactly how much they have to spend, but the more money you spend, then the more likely you would go to the restaurant, since it does make sense because it's an upscale restaurant. People, if they have money to spend, they will spend more. So this is how you will interpret the data, and make sure that you report all the items that needs to be reported, including the VIF, the multicollinearity diagnostics, which is the VIF over here. Okay.